Dear students, today we are going to discuss about the electron gain energy and electron affinity and also the periodic trends regarding these two. First of all, we will see what is the electron gain energy. So that is energy changes that occurs when an electron is added to a gaseous atom. That means it is something similar to electronegativity but not electronegativity, like this. You can think that there is an atom A in the gaseous state and electron is accepted by this A atom and it becomes A minus anion. We should either supply or some energy is released when this reaction happens, right? At sometimes we should supply some energy to give an electron to an atom. Sometimes when an electron is accepted by an atom, it releases energy. So that energy change is known as electron gain energy. So there are conditions. It should be in the gaseous state, right? It should be in the gaseous state to accept an electron. So first electron gain energy means taking one electron. Second electron gain energy means taking an electron by monovalent anion, right? Like that. Most of the times energy is released when an electron is added. But there are some situations where energy is absorbed when an electron is taken. Here you are given chlorine gaseous atom accepts an electron and becoming the chlorine minus anion. Factors affecting electron gain energy. So here first factor affecting the electron gain energy is electronic configuration. Here we should consider whether the atom is having a stable or half stable electronic configuration. Right? So if an atom is having a stable or half stable conditions, they do not like to take any more electrons because it harms their stability. We will take an example, nitrogen. Here nitrogen is having a configuration of 1s2, 2s2, 2p3. Here you can see 2p3 is half stable, and when taking an electron to this nitrogen, the stability of nitrogen is no more there. So it doesn't like to take any more electrons. So in such situations, repulsions become prominent. I will teach what repulsions and attractions is. Here like this. Nitrogen atom is there. Here's the nucleus, 2 electrons and 5 electrons. Like this. So this is the incoming electron. Like this. Then from the nucleus to the incoming electron, there is an attraction. But these outermost electrons repel these incoming electrons. All the electrons repel these incoming electrons. So, in each situation, there are attractions as well as repulsions, right? In each of the situations, there are attractions and repulsions, but the factor that becomes prominent decides whether energy is released or energy is taken when accepting an electron, right? If the repulsions are prominent, then more energy should be supplied to the element to give electrons to it. If attractions are prominent, energy is released when an electron is taken by that particular element. So here, when an atom is having a stable or half stable conditions, the repulsions become prominent because they do not like to accept any more electron. In such situations, the prominent factor is repulsions. So energy should be supplied for such atoms that have stable configurations. When an atom is having a stable configuration, we should supply energy for it to take an electron. For examples like nitrogen, right? If the energy is absorbed when an electron is taken by that particular element, we represent the electron gain energy to be a positive value, right? If energy is released when taking an electron by an element, that energy is a negative value. So that is the difference. The next factor affecting the electron gain energy is atomic size. So you have learned about this in the previous videos. When the atomic size increases, the nuclear attractions become low, like this. Here this is the nucleus and here is the outermost energy levels, right? So when the distance from the nucleus increases, what happen? Nuclear attractions become low. For the first energy level, there are more attractions and here it becomes less than this. And for the outermost energy level, even less attraction is there. So, when the atomic size increases, the nuclear attractions on the outermost energy level becomes less. So, in such situations, it is hard for this nucleus to attract incoming electrons. Right? We will compare two atoms with two different sizes like this. Here two energy levels and here 3 energy levels. And incoming electron is here. Like. So this first nucleus has a less distance with the incoming electron and this second element has a big distance with the incoming electron. So more nuclear attractions are from this first element. So it attracts the incoming electron very easily. And attractions are prominent in a situation with less atomic size. When the atomic size is less, attractions are prominent. So negative value of electron gain energy increases. You should remember this. When an atom takes an electron willingly, in such situations, attractions are prominent. If they do not like to get an electron, then the repulsions are prominent. When the atomic size becomes less, they like to take an electron because nuclear attractions are higher. So, in such situations, negativity of the electron gain energy value increases, right? When the atomic size increases, it becomes less negative. What I said is when the atomic size decreases, the negativity of the electron gain energy becomes more negative. Then there is a nuclear charge. So when nuclear charge increases, nuclear attractions between the nucleus and the outermost energy level receiving electrons increases. You have learned about these things in previous videos, so I am not going to elaborate this. Just remember that you know when the nuclear charge increases, the ZeF value increases, the nuclear attractions increase. So when nuclear attractions increase, it is easy for the atom to get electrons for it. So more negative value is therefore electron gain energy because it willingly take an electron. So electron enthalpy become more negative when nuclear charge increases. Now we will see the periodic trend regarding electron gain enthalpy. Here I am going to sketch a periodic table like this. And now so far we have discussed about three factors affecting electron gain energy. So I am going to give you the trend, teach you the trend using the atomic radius. You know that down the group atomic radius increases. Radius increases down the group. Radius increases. Across the period, radius decreases. Radius becomes low across the period. Radius becomes low across the period. So here we know that when the atomic radius becomes low, the electron gain energy value become more negative. So for this side, electron gain energy value become more negative. Down the group, atomic radius increases. When atomic radius increases, electron gain enthalpy becomes more positive. So here negativity becomes less down the group. So these are the two periodic trends that you should know. So you should remember here that across the period electron gain energy becomes more negative, and down the group electron gain energy becomes less negative. And there is another point that you should remember. In the elements with stable or half stable configurations, the electron gain energy value is positive. Exceptional cases, right? They have positive values. And there should be something in your mind. Group 18 elements doesn't have electron gain enthalpy value. They are almost stable. So they do not want to accept any more electrons, so they do not even have an electron gain enthalpy value. Now we will learn about the electron affinity. Electron affinity is the exact opposite of electron gain energy, right? Energy change that takes place when an anion loses an electron in gaseous state is known as electron affinity. So here an example is given. A minus anion in the gaseous state releases an electron and becomes a neutral atom in the gaseous state. Energy can be released or energy can be taken during this reaction. So that energy change is known as electron affinity. That change is known as electron affinity. Energy change that takes place when an anion loses an electron in the gaseous state, right? So it is equal in magnitude and opposite in direction to the electron gain energy. Electron gain energy is exactly opposite with the electron affinity. So here we learn about a periodic trend regarding electron gain energy. The opposite of that is true for electron affinity. We learn that across the period, electron gain energy becomes more negative. Electron affinity across the period becomes less negative. Down the group, electron gain energy becomes less negative, but electron affinity down the group becomes more negative, right? So that is a periodic trend regarding electron affinity. If we think about this, magnesium, for example, have plus 19 as its electron gain energy value, and magnesium has minus 19 as its electron affinity value. So here we can conclude that it is equal in magnitude and opposite in direction. So these both are equal in magnitude and opposite in direction. That is the end of the lesson today. Thank you for being with me till the end.